What's up, everybody? It's Dan from sagemathtutoring.com, and here are two problems I'm going to cover that have to do with managing exponents. So, we're going to look at these. These are relatively challenging. These are definitely a concept that can be challenging in general. So, looking at this first one, well, the fact of the matter is that you have this exponent of 3 that's on the outside, but I'm going to use PEMDAS. We're going to say, let's simplify everything inside the parentheses first. So we have a negative 3. I'm going to call that a negative 1, 3, just in case I need to take into account the fact that there's a negative 1 secretly there. We're going to say we got a b squared, we got a c to the 5th power, and that's all over c to the 2nd power, and then b to the... I'm going to assume that's a 7.
Yeah.
Okay, good. Yeah, I'm here with my friend, by the way, for the audience at home. So anyway, we have b to the 7th power down here. Now, I think we understand that there's 2 b's being multiplied together here. There's 7 b's being multiplied together here. So you can imagine a string of 7 b's being multiplied together here. I think anyone would agree that that this is going to cancel with that. These two are going to be gone entirely, and that's going to leave us with 5 b's multiplied together there. Similarly, you have a string of 5 c's being multiplied here. You have a string of 2 c's being multiplied there. So I think anyone would agree that these 2 c's are gone, and it's going to leave us with 3 c's being multiplied together there. All right. So I'm going to just represent this entire situation once again as, negative 1 times 3. The b squared is gone. We have a c to the 3rd left over, it looks like. We have a b to the 5th left over on the bottom. At that point, we can take advantage of the fact that when you have an exponent on the outside of a fraction, that exponent gets applied to everything. So it gets applied here, gets applied there, gets applied there, and it also gets applied down here. So I think it's probably smart to not get ahead of yourself. Don't try to do too much at once. So we're going to write down literally every step. So down here, we will have left over. In fact, I don't need the parentheses anymore. We will have left over negative 1 to the 3rd, 3 to the 3rd, and c to the 3rd to the 3rd. Some of you at home might already know what that is. We're going to have b to the 5th raised to the 3rd. So we're going to keep going. Negative 1 to the 3rd, that is an odd exponent. Negative 1 raised to an odd exponent is just going to be negative 1. 3 to the 3rd is 27. Let me make that nicer. 27. C to the 3rd is c to the 9th. So I'm just going to call that c to the 9th right there. Then we have b to the 5th to the 3rd. I think anyone would agree that that's going to be b to the 15th. Now, that's basically the answer. There's a chance that the teacher might accept something like that. However, it's considered better form to not write that negative 1 in the final answer, at least. You could have negative 27, c to the 9th, b to the 15th. And just to be on the lookout, sometimes the back of the textbook, if there's answers in the back, they might put that negative out front. So it might end up looking something like that, in which case that's fine too. So these are two perfectly valid ways of representing the final answer. So hopefully that makes sense. Moving on to this guy. All right, I'm just going to rewrite that one. This one looks terrible. So we have 3x to the positive 2 times y to the negative 2 times z to the 3rd all over x times y to the 4th, z to the negative 2. Everything's being raised to the negative 3. Okay, so here's the rule that I would strongly suggest when you're dealing with negative exponents inside this big fraction. You can think of the fraction as a two-story building. Anytime you have a negative exponent on the top floor, you shove it down into the basement and change the sign of the exponent. Anytime you have a negative exponent on the bottom floor, you yank it up to the top floor and change the sign of the exponent. Now, what does that mean? That means that this y to the negative 2 is going to get shoved down below, and it's going to become a y to the positive 2. that means that this z to the negative 2 is going to get yanked up to the top, and it's going to become z to the positive 2. So when I do that, which I would strongly recommend, I would recommend doing that because PEMDAS says we should simplify this parentheses first. We are going to have the 3x squared hanging out. We're going to have a z to the third still there, but remember we brought this z up, so that's going to be z squared. We're going to worry about that later. We're going to worry about that relatively soon. There's more that can be done with that. We still have this x down here. There is more to be done with that x, but we're not going to worry about it. We're only going to worry about the negative parenthesis or negative exponent stuff right now. So we have y to the fourth still down here. Nothing happened with that, but this y to the negative 2 just got shoved down below. So we have y to the positive 2. So I think that covers the negative stuff. So what did we do first? What we did is we made sure there were no negative exponents because no one likes to deal with negative exponents. They're ugly. They look bad. They look confusing. So you just immediately put them in that less confusing form. So here we are. Now we have a situation. We have x squared, which is fine, but that's above this thing, right? We have x squared above a single x. So actually, we'll take that. We'll take care of that. The reality is there's two x's being multiplied together here, and there's one x hanging out there. I think anyone would agree that that guy gets canceled, and that turns into a 1. So we're going to rewrite that accordingly in the next step. Now we have z to the third times z squared. This is not to be confused with z to the third raised to the second power. If that was the case, we would multiply these. But this is not that. This is a different thing. This is the same base, but two separate things getting multiplied to each other. It's not a single base being raised to a power twice. So you need to make sure that you realize that this is not the same situation as that. What you do in this situation is you keep the base and add the exponents, okay? So what you're going to have in the next numerator, at least, you're still going to have that 3. You're going to have an x left over, and you're going to have z to the 5th. Still have this negative 3 on the outside. Now down below, we're going to apply that very same rule. We have y to the 4th times y squared. That's going to be y to the 6th down there because we added the exponents. I think we're good to go so far with all that. All right, so what have we done? We have completely simplified the inside of the parentheses, which the P in PEMDAS says we should do. What did we do? We took care of the negative exponents we represented the negative exponents in the terms that had a negative exponent in a way that's less confusing. Then what did we do? We took advantage of the law, the fact that you can multiply this times that by adding the exponents. You can multiply this times that by adding the exponents. Now we're ready to go ahead and apply this negative 3 to everything. All right, there's 3 things on top you have to apply it to, and there's 1 thing down below that you have to apply it to. Now, for the record, there are multiple ways that you could do this, but this is the way that I would propose. So now we have 3 to the negative 3. Okay, fine. We're going to worry about that later. We have x to the negative 3. We have z to the negative 15, right? It's going to be z to the 5 raised to the negative 3, which means you're going to keep the base and multiply the exponents. We have negative 1, 5. And we're going to have y to the negative 18, it looks like. Now, you might be wondering, crap, we still have negative exponents. Well, yes, crap is right. We have to take care of these negative exponents now because typically teachers don't like it when there's negative exponents in the final answer. You're going to have to just do whatever you have to get rid of them. Well, the bottom line is we're going to just use the exact same rule and principle that we did before. Any term that has a negative exponent on the top gets shoved down below. Any term that has a negative exponent on the bottom gets yanked up top. So we're going to go ahead and just draw our fraction line and just do it accordingly. We're going to have a y to the positive 18 here. We're going to have a 3 to the positive 3. We're going to have an x to the positive 3. We're going to have a z to the positive 15. At that point, we're basically done. However, your teacher might really want you to scan the final answer and just make sure that you don't have any numbers raised to a power, because the truth is that you could actually turn that into 27, okay? So you always have to ask yourself, well, am I actually done? And after turning that into 27, you would be done. Now, there is a chance I made a careless mistake. You can let me know in the comments below if there was a careless mistake. I believe in this process, though. I believe in this order. I think that this is the order by which you should do things. I think you should adhere to PEMDAS, because why not? PEMDAS is kind of like a universal rule that you're supposed to be able to apply under any situation when you're simplifying stuff, and that's what we're doing. P stands for simplify the stuff in the parentheses. We did that first. Then we applied this exponent. The E stands for exponent. Then we applied the exponent after simplifying everything that was in the parentheses. And through the process, we ended up here. My handwriting's not that great because I wrote upside down, so hopefully it's legible. And hopefully that was helpful, and I will talk to you later.